Hello, welcome back. Today we are diving into the exciting world of Spring AI and explore how to build a retrieval-augmented generation or RAG application using Spring AI. First, what is retrieval-augmented generation? Retrieval-augmented generation is a technique for enhancing the accuracy and reliability of generative AI models with informations fetched from specific and relevant data sources. The application that we are going to build today will allow users to feed document to a particular location. The application will read the file from the location and convert them to chunks using Spring AI, and then it will persist the chunk in a vector database. Then we can ask questions based on the provided document. Alright, so what is Spring AI? Spring AI is an innovative project designed to simplify the integration of artificial intelligence into your applications. It is inspired by famous data frameworks like LangChain and Llama Index. Spring AI brings AI capabilities to the Java ecosystem, making it accessible and straightforward for developers. Some standout features of Spring AI includes portable API support, which provides seamless integration with various API providers, structured output, integration with various vector database providers. It also supports tool calling. It also provides APIs for data ingestion using the ETL framework. Alright, after that short introduction to Spring AI, let's dive in to build our RAG application. First, open any browser of your choice and type Josh Long's favorite place after production, that is start.spring.io, and press enter. Alright, here I will select Maven as the build tool. I will select Java as the language. I will select a Spring Boot version of 3.4.3. At the time of recording this video, the stable version of Spring Boot available to me is 3.4.3, which might change in your case. Select the stable released version. I'm not going to use the snapshot version since they are still under development. The group name I gave it as com.craig.snap.mac. The artifact ID I gave it as Spring AI Chatbot. And the name of the application is Spring AI Chatbot, and the description RAG using Spring AI. The package name is com.craig.snap.make.spring.ai.chatbot. I will pack the application as jar and I will use Java 23. Now let's add the important dependencies that we will need for this application. Click on Add Dependencies. First, I will add web. Then I will add Chroma. Now Chroma is a famous vector database. We are going to use Spring AI to connect to Chroma today. Next, I will add Ollama. I'm using this dependency to connect to the local LLMs that I have pulled in my machine using Ollama. If you want to connect to the famous AI providers available in the market, you can install their dependencies as well. Example, if you want to use Anthropic, you can search Anthropic Cloud and install these dependencies. Next dependency that I will need is Spring Integration. I will use Spring Integration for periodic file ingestion from a directory. Next, I will use Tika to extract text from a variety of document formats. Next, I will use DevTools for hot reload. Next, I will use Docker Compose to spin up the Chroma DB as a container. Finally, I will use Lombok. Once all these dependencies are added, I will click Generate and I will save it. Now, before we start with the code, please ensure we have already installed Maven, Java 23, Docker Desktop, and Docker Compose. I will provide the links to the resources which will help you to install these prerequisites step by step. We are also going to use IntelliJ IDEA and Ollama. I have a separate tutorial which shows step by step how to install IntelliJ IDEA, Community Edition, how to install and pull open source LLMs in your local machine using Ollama. I will provide the links to these tutorials in the description of this video. You can also navigate to these tutorials using tooltip icon on the top right corner. Now, first, let me unzip the downloaded project in my file system. This is the project that we created in start.spring.io. I will open this project with IntelliJ IDEA. I will open this folder first, then I will open IntelliJ IDEA Community Edition. I will click Open. I will navigate to the directory where I have this project. I will go inside the project and I will select pom.xml and I will click Open. And I want to open it as a project. And there you go. We have the project opened in IntelliJ IDEA. Okay, before I start with the coding part, let me see the prerequisites are up and running. I will open my terminal. If you are using a Windows machine, you can open command prompt. First, I will check Java is installed. Yes, I have the Java 23 installed in my system. Next, I will check Maven is installed in my system. And yes, Maven is installed in my system. Next, we have to ensure that Docker Desktop is installed and running in our system. Before we start with the code walkthrough, don't worry about the speed at which I show you the code. Try to understand the core concepts behind it. I will provide the complete code in the description of this video. Alright, now let's dive into the exciting part. I will create 3 packages inside my root package. I will right click and new and I will say package. And first package will be configurations. Second package will be models. And the third package will be REST. Alright, now let me create the classes that we will need today. First, I will create a class inside the configurations package and name it as AI configuration. Right click, new Java class, AI configuration, and press enter. I have used a class level annotation named configuration. Now this annotation tells Spring that this class is the source of verb in definitions. Then Spring application context will look up for all the methods annotated with @bin and create a bin out of them. We will also need another configuration class for our ETL pipeline, and I will name it as ETL configuration. We will also need an implementation of Web MVC configurer in order to set up settings for CORS. Now let's create the REST controller that we will need today. I will name it as AI REST controller. Then I will use @REST controller annotation. Now let's create few records that we are going to use today. The first one is human message. Press enter. The human message record will contain fields like query, which will come from the user, the history of the conversation, and the session ID. Now let me create another record and name it as AI message. The AI message will have only one field with the name of content. And there you go. We have created all the classes that we will need today. In order to save some amount of time, I will copy the code that we will need and I will explain what it does. Okay, since we are building a RAG chatbot, the first thing we need to do is set up the ETL pipeline, which will help us to drop a file to a folder, and the application will read the file, extract the text content from the file, convert them to chunks. Then the chunks will be converted to vectors, which will be stored in a vector database. In our case, the vector database is Chroma DB. Spring AI provides three important components for the ETL pipeline. We have the document reader, then we have the document transformer, and then we have the document writer. Using the document reader, we will read the documents. Then we will use the document transformer to convert them into list of chunks. And finally, we will store the chunks in a vector database using document writer. First, let me open the pom.xml and add the Spring integration file dependency, which will allow us to read the files from a folder periodically for our ETL pipeline. Since we added Docker Compose dependency along with Ollama and Chroma DB while creating the projects, that created a compose.yaml at the root of our application. Let me open this compose.yaml. I'm not going to use Ollama as a Docker container, but I will use the Ollama instance installed in my machine. Now, if you want to learn how to install and use Ollama to pull local open source LLMs in your machine, watch one of my previous tutorials. I will provide a link in the description of this video. Now, let me remove the Ollama service instance from the compose.yaml. Also, I will replace the Chroma container definition with this content. What this will do is, when we start the application, it will spin up a Chroma DB container and expose the port 800 for us to communicate with it. Next, let me open the application.property and place some important configurations that we will need in the application. Here, I have specified the Ollama model that we are going to use and the Ollama chat completion endpoint. Now, how do you get the Ollama model name? First, let me open terminal. If you are using Windows machine, open command prompt. Ensure your Ollama server is up and running. Then you can type Ollama list and it gives me all the Ollama models that I have installed in my machine. We will use nomic embed text for embedding, and we will use Win 2.5 Coder 14 billion parameters model for our chatbot. Here, since we are running the Chroma instance as a Docker container, I have given the local host and a port was 8000. These configurations are related to Docker Compose. What it says is, when we close the application, it gracefully deletes the container and its associated volume. Our ETL pipeline will continuously pull to this location that we will specify and pick up the files that we place here. Now, let's create and understand the important Spring Beans that will help us with the ETL pipeline workflow. Let me open ETL configuration class that we created before. The first thing that we need to do is to add enable integration annotation, which will help enable Spring integration infrastructure, which in turn will help us to periodically read files from a location in our case. Next, I have added SLF4J annotation, which will help to log messages in this class. Next, I have defined two value annotations, which will help us to read the properties that we defined in the application.property. First, it will read the location of the directory where we will place the file, and next it defines a pooling rate. Now, this bean will help us to create an integration flow. Here, we are using the inbound file adapter, which will periodically pool using the pool rate specified in the application.properties. Then, we will read the file from the location specified in the application.properties. Here, we will filter only the files which are text or PDF or Word document. Then, we will use Spring Integrations Watch service to continuously monitor for file created events. And finally, the file as a message will be pushed to a channel we defined below. Here, we have created a point-to-point channel. Think of it like a pipe where at one end, the file message will be pushed. Now, this integration will read the file from the pipeline we defined above from the other end. Then we will read the file name from the message that we received, convert it to a Spring resource type, and finally create an instance of TK document reader. Now, in this line, we will read all the contents of the document. Next, we will use the token text splitter to convert that whole large document into multiple chunks. Here, we specify that each chunk should not exceed 500 tokens. Think of tokens like a word of 4 characters. Here, we specify that while splitting the large document into smaller chunks, the chunk size should not be less than 100 characters. Now, if the chunk size is less than 20 tokens, don't embed the chunk. Instead, try to merge with the other chunks if possible. Finally, the total number of chunks that we divided this whole document into should not exceed more than 100. Using this property, we ask token splitter to keep the line breaks, the paragraph breaks, etc. And finally, we store the list of chunks that we got into the vector store. I will explain the bin definition of the vector store in the next section. And there you have it, the complete end-to-end ETL pipeline to ingest documents in the vector store using Spring AI. Now, let's understand the important beans of AI configuration class that will help us to retrieve the persisted documents, generate large language models answer using the documents as context. First, we will use the value annotation to read the following properties from the application.properties. First, let's read the Ollama model name that we are going to use. Then the Ollama chat completion endpoint. Then the Chroma API endpoint. This bin will help us to interact with the Ollama chat completion API endpoint using HTTP REST. Then we have this bin which will help us to create Ollama chat model. Now think of a chat model like an interface to talk to the LLM in natural language. We will use chat models Fluent API to provide the Ollama API endpoint and the model name that we want to interact with and the temperature setting to decide the creativity of the model interaction. Now this bin will help us to create an in-memory concurrent hash map to store the conversation between us and the LLM. Think of it like a bucket to hold the conversation between us and the LLM. Later, provide this conversation as history to the LLM to improve the context of the conversation. Using this bin, we are creating a simple HTTP client builder, which we will pass to Chroma API later on. Now this bin will create an instance of Chroma API where we will provide the Chroma URL that we read from the application.properties and the REST client builder that we created above. This bin will also help us to talk to the Chroma DB that we are running as a Docker container via HTTP with the help of REST APIs. In this bin, similar to the chat model, we are creating an embedding model. Think of this like a translator which will take your natural language and translate them to vectors. In our ETL pipeline, when we stored those chunks to Chroma Vector Store, the Vector Store internally uses the embedding model, convert the document to vectors before storing them. Also, when you ask a question, the Vector Store will first translate your query to vectors and do a cosine similarity search between the vectors to find all the similar documents. Here, we are creating the Ollama embedding model using the Fluent API by providing the Ollama API that we created above, and also we provide the embedding model that we will use to convert the natural language into vectors. Here, we are creating a Chroma Vector Store by providing the Chroma API that we created above in the embedding model. Then we define a collection name as RAG. Now think of collection like a folder of particular types of file, and when you need a file, open the folder and read the file from it. Then we initialize the Vector Store and create the collection name RAG for us. Now think of Vector Store as a manager who knows where all the files are and how to use the translator defined above to fetch the relevant files. Now this bin will help us to create a chat client. Think of the chat client as an interface which will allow us to talk to the chat model that we defined above. The chat client help us to define system prompts, user prompts, tool calls, advisors, etc. Here, first we are using the Fluent API. We will pass the Ollama chat model that we defined above. Then we provided a default system prompt asking it to be a helpful RAG assistant and always provide the answer based on the provided documents or provided information. Then we added few default advisors. Think of advisor as a powerful middleware to hook in, intercept, modify, and enhance our interaction with the AI model. First is the message chat memory advisor. The message chat memory advisor will add our in-memory conversation as history to improve our conversation context, the LLM. We don't need to manually provide a conversation history like we do with other frameworks like LangChain. When we will invoke this chat client bin, we need to provide a unique ID, and Spring AI will group and store all the conversation between us and the LLM having the same ID as one conversation, and then it will pass the conversation as history to LLM to improve the context of the conversation. Example, when you ask an LLM what is your name, it might not know your name, but when you tell the LLM that my name is John, and the next time you ask the LLM your name and provide the conversation history to the LLM, it will correctly tell your name. In our example, we will use the in-memory chat memory, but you can also use other persistent chat memories. The next advisor we use is question answer advisor. It is a very basic out of the box implementation to help us with RAG functionality in Spring AI. What Spring AI does is when we ask the query, the advisor will use the embedding model, convert our query to vector, use the vector store to retrieve the relevant documents and pass the document to the LLM, generate the answer based on the document alone. Now, while creating this advisor, we are telling Spring AI to retrieve all the documents whose similarity score between the vector is more than 0.5, where the score of 0 means very disjoint vectors and 1 means very identical vectors. And there you have it. We have defined all the bins that we will use today to interact with the LLM. Now, let's create a REST endpoint in the AI controller. First, we have exposed a HTTP post endpoint where the request body is the human message that we created before. We have also injected the Ollama chat client bin that we created in the configuration class. First, we will call the prompt method on the Ollama chat client, which will in turn help us start building the prompt. Then we pass the user query that we received from the request body to the prompt. Now, if you remember, while creating the chat client, we provided the in-memory chat memory advisor. Here at runtime, we will provide the conversation ID to the advisor. Spring AI will group all the conversations having the same session ID as one conversation. Now, when the session ID changes, a new conversation is created. And finally, using these two methods, we will stream the string content asynchronously to the caller of the endpoint. And there you go. You have everything we need to start interacting with this RAG application. Now, let's start the application. Before we start the application, let's create a directory where we will place our files, which will be picked up by our ETL pipeline. Right click, new directory. I will name it as documents. Then I will right click, copy path and reference and absolute path. And I will give the path to this property. Now click on run from the top menu, then click run again. Then edit configurations, click on the plus icon here and select Maven. I will give a name as run app and the command line will be spring boot run. Apply and run. And there you go. We have started the application. Now, if you notice something as we start the application, and since we were using Spring Boot Docker Compose support and there was a composed file at the root of our project, the Spring Boot Docker Compose support read this file, created a container for us. That means the Chroma DB is now running as a Docker container in our machine. And finally, the application started at port 8080. I have downloaded a short story which we are going to index today. What I will do is I will put this story into the document folder that I have created, and the ETL pipeline that we have in place will automatically pick up this file, create them into chunks and store them in the vector database and convert them to vectors. And then I can ask query against the documents. Let's check that in action. First, I will put this document, which is a story in our case, into the documents folder. Alright, we got an error. Why? Because our vector store is dependent on the embedding model, and the embedding models that I'm using is using Ollama since I'm running them locally. Now, the first step is to start the Ollama server. But let's say you are not using the Ollama server and you are using the various AI providers available in the market. You don't have to do this step first. Let me start the Ollama server. I will open the terminal or the command prompt in case of Windows and type Ollama serve to start the Ollama server. And then we have the Ollama server started. Next, I will restart the application. And there you go. What happened here is first, the ETL pipeline read the file. Next, it converted the whole documents into 10 chunks. And then it stored those chunks in our vector database. Now, let me open the terminal or command prompt in case of Windows. And I will use curl to call the HTTP endpoint that we created. I will say curl, this is the endpoint. The content type will be application JSON and the data that we want to pass, which will get converted into the request body. First field is the query and second field is the session ID, and we are passing an empty message array. And there you go. The application was able to retrieve the document from the vector store and generate the answer based on the context. But this is a boring interface, right? Let's run a Svelte app that I built, which will help us to communicate with the RAG application that we built today using Spring AI. Now, I will help you to set up a Svelte Kit app, which will help us to interact with the Spring AI RAG application that we built in a user-friendly way. First, let's clone the Svelte Kit code. I will provide the GitHub link in the description of this video. Click on code and the copy icon, then open terminal or command prompt in case of Windows. Then I will say git clone -ob. Then I will provide the branch name that I want to clone, and I will clone only this single branch. Then I will paste the clone URL that I have copied and I will press enter. And there you have it. We have cloned the repository in our file system. Then I will do cd, the name of the application, enter. Now, before we start the app, please ensure Node.js is installed in your machine. I have a separate tutorial which will teach you step by step to install Node.js and pnpm. I will provide a link to the tutorial in the description of this video. Once I am inside the Svelte Kit code, I will say pnpm install, and this will install all the dependencies required by this project. And there you go. All the dependencies are installed. Now, let me run the application. I will say pnpm run dev -- open, and it will open the application in the browser. Now, before I start talking to the RAG application that we built, we have to ensure that our Spring AI RAG application is up and running, our Ollama server is up and running, and my Spring Boot application is up at port 8080. Now let me check if my Ollama server is up and running. Yes, my Ollama server is up and running. You can see the logs here. And even my Svelte Kit app is up and running in port 5173. Now, since this is the PDF that we indexed previously, let me ask question related to this PDF. Let me ask about Havana Rivera Hotel. I will say, tell me about Havana Rivera Hotel. Press enter. Now, when the Spring application receives this query, the chat client will use the question answer advisor and in turn the vector store to first convert this query into embeddings. Then the Chroma Vector Store will retrieve all the documents which are relevant to the query using the cosine similarity. Then it will provide the documents and the query to LLM to generate the answer based on the context. And there you have it, folks. We have built a fully functional RAG application using Spring AI, Chroma DB, and Ollama. If you found this tutorial helpful, make sure to like, subscribe, and hit the notification bell so you don't miss any future AI projects. Drop a comment if you have any questions or suggestions for future videos. Until next time, happy coding.